This is section 2.2, and it's called Prime Numbers, Factors, and Reducing to Lowest Terms. And so probably one of the key things we're going to do in this section is just reviewing on how to reduce to lowest terms. So what we're doing here is we're taking a fraction and we're basically trying to make the numbers in the fraction equivalent but smaller. So for example, if we have 4 over 8, an equivalent fraction would be 1/2, because we have a whole pie and it's divided up into 8 pieces, and 4 of them is how many parts you're taking. So you're taking 4 out of the 8 pieces. Well, 4 is half of 8, so therefore 4 over 8, the equivalent fraction reduced is 1/2. So notice what we've got there. Instead of a 4 we have a 1, instead of an 8 we have a 2. So we've made the numerator and the denominator smaller, so therefore we call it reduced. But before we get into different methods as far as reducing, let's look at a couple different terms or definitions here. First one is called a prime number, and the second one is called a composite number. So if you know what a prime number is, you'll know what a composite number is. Alright, a prime number is any number that is bigger than 1 that only itself and 1 can divide into it. So, for example, the number 7. It's a number bigger than 1. 7 goes into itself 1 time, and 1 goes into 7 times, but nothing else divides into it. 2 doesn't, 3 doesn't, 4 doesn't. No other number will divide into it. A composite number are all the other numbers that are not prime. So, for example, if we put 8 up here, what numbers divide into 8? Well, 8 divides into itself just like a prime number. 1 divides into itself just like a prime number. But also 2 and 4 divide into 8 evenly. 2 goes into 8 4 times and 4 goes into 8 twice. So therefore it's a composite number. So let's look at some different prime numbers. 3 is a prime number. Nothing divides into it except itself and 1. 5 is a prime number. 7, and you're thinking, oh great, odd numbers, but 9, what goes into 9? 1 does, and 9 does, but 3 also goes into it, so that's not a prime number. 11 is, 13 is, 15 is another odd number, but 3 goes into 15 and 5 goes into 15. Now notice what's happening here. Are you noticing that all of the prime numbers are odd? It's not all the odd numbers, but, oops, not that one, but every one of these prime numbers is an odd number. So that's one thing that's nice when you're looking at prime numbers. If I were to ask you, is this a prime number? Well, if it's an even number, you know automatically it's not, because all even numbers 2 go evenly into it, besides the number itself and the number 1. So you'll know when you see an even number that it's not prime. Now this next bit of information we're going to go over oftentimes is very frustrating to students because it takes time. Not everything in math has shortcuts and is quick and easy. Sometimes you have to do the hard stuff. You have to do a little bit of extra work in order to find the answer. And that's the case in this next section here. We're going to be doing what is called finding the product. We're looking for the product of prime factors. And if you remember, product is the answer to a multiplication problem. So what we're going to be doing here is we're going to take a number and we're going to reduce it to its prime factors. Factors are numbers that we multiply in order to get the original number. So for example, the factors of 6 are what numbers can I multiply to get 6. So 2 and 3 are factors of 6. If we multiply them, we get 6. A factor of 36 would be 18 and 2. 18 times 2 is 36, so they're both factors. All right, what I'm interested in is not only the factors of a number, I'm looking at the prime factors of a number. So, for example, if I have the number 36, I'm looking at two numbers multiplied together, or I'm looking at numbers multiplied together, sometimes it's more than two, multiplied together that give me 36. And of those numbers multiplied, every one of them has to be a prime number. So, even though 18 times 2 is 36, 18 is not a prime number. So what I have to do is I take 36 and I find two numbers multiplied together to give me 36. In this case, again, 18 and 2. Because 18 is not a prime number, I've got to find out what two numbers multiplied together give me 18. So 9 and 2. Well, 2 is a prime number, so this 2 and this 2 are both prime numbers, but this is not a prime number. So then I have to reduce it down to two numbers multiplied together to give me 9. And in this case, it's 3 and 3. And both of those are prime numbers. So, this, and this, if I were to multiply all those together, 2 times 2 times 3 times 3, so 2 times 2 is 4, times 3 is 12, times 3 is 36. If I multiplied all four of those together, I get 36. And because they're all prime numbers, and because they're multiplied, they are the product they are the prime factors of 36. So let's do a few of these, and if you remember from a long time ago, you might have used what is called a factor tree, and that's what I'll be using here. And a little bit different than what the book does, but I like it better. And I put my number there. And I notice my number is even, so I know that 2 goes into it. So I'm just going to put a 2 there. So what I'm doing is at the end of these two lines, I'm going to put the numbers that multiply together that give me 60. So in this case, it's 2 and 30. And when I do that, I look at each one of those numbers and I determine if one of them or both of them are prime. 2 is prime, so I circle it because then I know I'm done with it. And then I draw two lines from the 30 since I know it's not a prime number because it's even. So I'm going to put a 2 there because I know 2 goes into any even number. And 2 times 15 gives me 30. 2 is prime. Is 15 prime? No, because 3 and 5 go into 15. And now I ask myself, is 3 prime? Yes. Is 5 prime? Yes. And there's nothing left to divide, so I'm done. Everything at the end of my lines are circled, so I know I'm done. So my product of primes looks like this. 2 times 2 times 3 times 5. And that is my answer. Now let's look at a number such as 108. 108. I'm going to draw two lines, and it's an even number, so I know 2 goes into it, and it goes into it 54 times. So I circle my 2 because it's prime. 54 is an even number, so I know 2 goes into it, and 2 goes into it 27 times. Circle my 2 because it's prime. 27, is it prime? No, it's not, because 9 goes into it 3 times. 9 times 3 is 27. Is 9 prime? No. Is 3 prime? Yes. So because 9 is not prime, I draw two lines off of it. What goes into 9? 3 and 3. And we already know that 3 is prime, so I'm going to circle both of them. Notice at the end of my lines, all the numbers are circled now, so that tells me I'm done. And I put my numbers together in the right order, all the 2's together, all the 3's together. So if I were to multiply those, I would get 108. Okay, because the 2 appears twice. I'm going to write it as 2 squared. And because the 3 appears 3 times, I'm going to write it as 3 cubed. It's just a shortcut way of writing your product of primes. 2 squared times 3 cubed. Okay, in this next section of 2.2 that we've been working on, we're going to start reducing fractions. And this is where the product of primes that we've been doing with our little factor tree really does help us out here. All right, we're going to start with something like 12 over 15. And we're going to try to reduce that. And you might be able to reduce that in your head. You might be able to reduce it with pen and paper, fairly simple, without putting a lot of mathematical work into it. But I'm going to teach you how to use the factor tree, because when you have numbers in the hundreds and thousands and you're trying to reduce those without a calculator, you need to know how to do this method. So what we're going to do here is we're going to take the 12 and we're going to make a factor tree. So because it's even, I know 2 goes into it 6 times. Circle that because it's prime. Draw a line here. 2 times 3 is 6. 2 is prime, 3 is prime. So my prime numbers for 12 are 2 times 2 times 3. So if I multiply, 2 times 2 is 4 times 3, I get 12. Now let's do the same thing with the 15. 15 is not even, but I do know that 3 goes into 15 5 times. Are both of those prime? Yes, they are, so we're done. Okay, so I've got the product of primes on top, and I have the product of primes on bottom. And this next part that I'm going to show you how to do is we are going to cross out similar numbers in our numerator and our denominator up here with our prime factors. So we're going to take our 3 and cross it out, and this 3 and cross it out, because really what this is we just got rid of 3 over 3. And if you remember from the last section, any number over itself is equal to 1. 1 doesn't change any of this, so we go ahead and just cross those out. Okay, which leaves me with 2 times 2, which is 4, over 5. So 12/15 reduces to 4 over 5. So let's look at one like 20 over 24. I'm going to make my factor tree with my 20. And I get 2 and 10, circle the prime, even, so I know I have 2 and 5, circle the prime, and that's prime. So the number on my 20, instead of my 20, I'm going to put 2 times 5. And now let's find the product of primes for 24. And again, it's even. 12 is even. 6 is even. And 3 is prime. So I get 2 times 2 times 2 times 3. And then I cross common thing. 2 and 2, I can cross those off. That 2 over that 2, I can cross that off. So I'm left with 5 over 2 times 3 is 6. So these are both equivalent. It's just that is the reduced fraction of 20 over 24. So some of the problems may give you a fraction such as 6 over 42, and they may ask you to reduce it to lowest terms. Again, factor tree. 2 and 3, both of those are prime. I'm done. So I'm going to put 2 times 3 there. 42. Even number. Prime. 21 is not prime. 3 and 7. Both 3 and 7 are prime, so I am done there. So 2 times 3 times 7. And then all I have to do is cross out what's common. And I get 2 over 14. And notice that can be reduced because they're both even. So that means I made a mistake here, and that is I didn't cross out those 2's. Okay, so notice I crossed out my 2's, I crossed out my 3's, and what do I have left? I have left a 7. Well, what does that mean I do on the top? Whenever you cross out everything on the top or everything on the bottom, there's always a 1 there that you assume is there, because this is 2 times 3 times 1, this is 2 times 3 times 7 times 1. Okay, so assume that there's always a 1 left even when you crossed out everything else, because there can't be a 0 up there. It has to be a 1. Alright, so what if we had something like negative 105 over 30? What we do is we completely ignore the negative until we get to the end. So we take our 105 and we do the factor tree, and 105 is a multiple of 5. So I'm going to say 5 times 21, and that's prime. 3 times 7, both of those are prime. So my numerator is going, I'm going to keep my negative there. 3 times 5 times 7. And let's take our 30. That's going to be 2 and 15. Prime. 3 and 5. Prime, prime. So 2 times 3 times 5. So what I'm going to get rid of is that and that and that and that. And what do I have left? I have a 7 over 2, and I also have this negative that goes right there. So my answer is negative 7/2, and that is lesson 2.2.